sketch and graph the following equation. So I'm going to go write the y equals. I'm going to clear that out. I'm going to type in x cubed minus 27x, and I'm going to graph it and see if I get all the information I need. No, the window is not sufficient. So on their graphs, notice, it goes from -7 to 10 on the x values, and then -70 to +70 on the y values. So I'm going to change my window to what they have. -7, not -7, -7 to 10, and then -70 to 70. -70 on the y value to 70 on the y value. And I'm going to graph that. And now it'll give me the graph just like it looks for them. And let's see which one that matches. Immediately, it cannot be choice C, because C is only a parabola. It starts down on the left and goes up on the right, so that gets rid of choice A and choice B, so automatically has to be choice D. It wants the relative extrema, so let's see what it asks for first. First, it asks me for both. When it says extrema, it wants the min and max. So I'm going to give it the maximum first, because that's what comes first. So I'm going to hit second calc, find my max. I have to bring this over to the left, so I'm using the left arrow, bringing it over. I'm going to hit enter. I'm going to use the right arrow, bring it over, and then enter again. And that's going to give me -3, 54. Now I'm going to get the maximum. I'm going to get the minimum. So I'm going to hit second calc, and this time I'm going to get the minimum. I have to scroll until I get just to the left. It's looking for the left bound. Notice it says the word left bound. So I want to get a little bit to the left of the minimum, and then I want to go to the right of the minimum. That's why it's asking for the right bound. And that's going to be 3, -54. Notice it's a little symmetric. So that's going to be 3, -54. Now this is an important question. What are the coordinates of the inflection points? Now the inflection point is that spot where the graph goes from concave down to concave up. That spot where the concavity goes from down to up is where the inflection point is. To find that inflection point, what you need to do is take the derivative of this. So the derivative is going to be 3x squared minus 27. You need to take the derivative of that again. So the derivative of 3x squared is 6x. That's it. The derivative of 3x squared is 6x, and the derivative of -27 is 0. Now here comes the moment. To find an inflection point, you set the second derivative equal to 0. So when I solve this, I get x value is 0. So the x value is going to be 0. Now I need to know what the y value is. I'm supposed to take this and plug it back into the original. Now I can mathematically see really quickly that the y value is also going to be 0. But let's do it on the calculator. I'm going to hit second calc, and I want to find the value. I want to find the value. So I'm going to click on value. When the x value is 0, when I hit enter, it will give me the y value. And it plugs it in and does the arithmetic for you. So that's going to give me a point of inflection at 0, 0. Now we discuss interval increasing, interval decreasing. It's increasing from -infinity up until -3. That's that value. It's also increasing from 3 to infinity. I like to look more specifically where it's decreasing. Notice it's decreasing from -3 to 3. It's going downhill from -3 to 3, and that's the only spot. So I'm going to look for that in my answer choices. Notice where it says decreasing everywhere, decreasing up until 0, decreasing on the right side, and here it is. It's decreasing on -3 to 3. It's actually choice A. It's actually choice A. Concave up, concave down. Now it's concave up from 0 to infinity. It's concave down from -infinity to 0. Concave up from 0 to infinity. Concave down from -infinity to 0. Concave down from -infinity to 0. Concave up from 0 to infinity. I lost it. Concave down. Good. And nope. It's concave up for some. It's concave up. No. It's concave down from -infinity to 0. Concave up, 0 to infinity, yes. Concave down, -infinity to 0, yes. It would be choice C.
Here.
Number 10. Quiet down, please.
Oh, sorry.
All right, for number 10, same thing, we want to graph it. So I'm going to go to y equals to -x cubed. So remember, we have to hit the negative button. Plus 3x squared minus 4. Before we graph it, we'd like to look at the scale that they have on their graphs. And notice their scale on their graph is the 10 by 10 window. So we're going to go to window and change it to the 10 by 10 setting. -10, 10. And now we'll graph it, and we'll get a graph exactly the way it's going to be symmetric to where proportional to their graph. So right now, it's not A, that's too far off to the left. It's not B because the end behavior is incorrect. It's not C because, again, the end behavior is incorrect. It has to be choice D. And the question begs, what are the extrema? So that's going to be the max, the min and the max, this min and this max. And we have to place both of them in that choice A. So I'm going to hit second calc and find my minimum first. And it's right on it, basically. I believe that's going to actually be my minimum. I'm going to left bound it a little to the left. I'm going to right bound it a little to the right. I hit enter again. And again, that strange number there is representing 0 because it's times 10 to the -7. So it's going to be 0, -4 is my minimum value. Now I want my maximum value. So I'm going to hit second calc scroll down to maximum. I'm going to get to the left side of that maximum. Then I'm going to get to the right side, the right bound of that maximum. I'm going to hit enter again, and that maximum is going to be located at 2. So this represents 2. We ignore that long string of decimals to the 6. And again, this is -1 times 10. The e means times 10 to the exponential to the -12. So that's going to be 2, 0. So those are my relative extrema, a min and a max. Not wants to know what the inflection points are. So once again, to get the inflection point, what we do is we come up to this original equation. We take the derivative of it. So the derivative is going to be -3x squared plus 6x. Not done. We take the derivative of that. The derivative of -3x squared plus 6x is -6x plus 6. Now, once we have the second derivative, we set that equal to 0, and then we solve it. So x equals 1 is my value, my x value for the point of inflection. Now, I'm going to go back to my graph. I'm going to hit second, calc, and I'm going to plug that value. Notice on that value, enter, and I'm going to plug in that value of 1. And notice it's just at that point of inflection where it goes from concave up to concave down. So the coordinate is 1 and -2. Now it's going to ask me particulars about it. On what intervals is it increasing? What intervals is it decreasing? Well, let's notice that it's increasing only from 0 to 2. It's increasing only from that 0 to that 2. Increasing from 0 to 2. And that's the only one that shows that. So it must be choice C. Concave up and concave down. So the point of inflection, it was at 1, -2. So it's concave up from -infinity to 1, and concave down from 1 to infinity. Concave up from -infinity to 1. It's concave up from -infinity to 1. So we have a choice between C or D, and concave down and 1 to infinity, and it's only that one. Number 11 is another multitask question. Again, we're just going to type it in. I'm going to hit y equals, and then I'm going to clear it out. X cubed, hit the X button. Caret button, 3, right arrow, -3x squared, -72x. I'm going to graph it. Oh, before I graph it, I'm going to go to their graphs and see what the windows are. Notice, these windows are really exaggerated. 10 to 10, -10 to 10, but -340 to 340. So I'm going to change the window. That's good, -10 to 10, but I'm going to change this to -340 to 340. And now my graph will be exactly the same proportion as theirs. So let's take a look. Notice, it can't be choice A. The end behavior is wrong. It looks like it could be choice B. It could be choice C. It can't be choice D. Notice it seems to go from 0, 0, and this one seems to go from 0, 0. So we're going to take, yeah, it has to be choice C. It has to be choice C. We want to find the relative extrema. So we're going to look for our max first and then our min. So we're going to hit second, calc, max, left bound it, right bound it, hit enter again, and that's at -4, 176. -4, 176. Now we have to find the relative min. We'll hit second calc, min. I'm going to left bound it. I'm going to scroll over, enter, right bound it, enter, hit enter again. That's going to be 6, -324. 6, -324. Now it's going to ask for the inflection points. So let's take the derivative of the original. So the derivative of x cubed is 3x squared. The derivative of -3x squared is -6x. The derivative of -72x is -72. That's the first derivative. Now I'm going to take the second derivative. That would give me 6x minus 6. And then I set that equal to 0. Solve that. X is going to equal 1. So my point of inflection is at x value 1. Now to find the y value, I hit second, calc, and I go to value. And I plug in x equals 1, what I got from solving for the inflection point. That's going to be 1, -74. And notice that's where it changes from concave down to concave up. It is the halfway distance between there and there, but it's a little bit more accurate to find it using the second calc function. And I can type any value there. It'll give me some random value at 2. Whoops. It'll tell me what the values are at different places. Now it wants to know the interval that it's increasing or decreasing. So from our graph, we notice that it's increasing from -infinity to -4, and then from 6 to infinity. And it's decreasing from -4 to 6. So I'm going to use that it's decreasing from -4 to 6 to eliminate my options. Notice, I see immediately that there's only one choice where it's decreasing from -4 to 6. So it's going to be choice B. Intervals where it's concave up and concave down is concave up from 1 to infinity. Concave up from 1 to infinity, concave down from -infinity to 1. It's going to be choice B. Interpretation problems. So you have to interpret where it's concave down. Notice it's concave down at 1, 5. So at 1, 5, notice this one is concave up. So it cannot be choice A. says it has to be concave down at 1, 5. This is concave up at 1, 5. Now, both of these look to be concave down around 1, 5. Maybe not this one so much. So right now, I'm thinking it's either C or D, because they both fit the concavity. Concave up at 5, -3. So again, they both could be that. And the point of inflection, notice, is going to be about halfway. Notice it's going to be about halfway. And this one is in the negative realm. And this one is in the positive realm. So at 3, 1, the point of inflection. So it's going to be choice C. Another interpretation, and this one is a little tricky. So we have a revenue function, we have a cost function. And then we need to figure out what the profit function is. And the profit function is going to equal this minus this. So it's going to be negative 0.5x squared. And then I have to do 60 minus 5, so plus 55x. And then I have to minus 30. So notice, I have a line that goes through plus 30, and I have a parabola that goes through negative 30. So they're symmetrical. One's above by 30, and one's below by 30. And this is a really tricky graph. Immediately, that's positive 5x plus 30. So it can't be this one because it goes all the way up to about 2,000. That's way higher than 30. It cannot be choice A. Choice B looks good. Choice C, that's negative, not positive line. So it cannot be choice C. Now, it's difficult to see the difference between D and B. But notice, this one, it would go way down lower than negative 30. This here is actually positive 30 on the line. You can barely see it. It looks like it's 0, 0, but it is not. And this would be negative like 500. So it has to be choice B. Graphical analysis. So the speed at which the absolute maximum gasoline mileage is obtained. So the max is right around here, and that speed is going to be at 60 miles per hour. The speed at which the absolute minimum gasoline mileage is obtained. So the minimum would be over here, and that would be 5 miles per hour. Notice this here is not 0, it's 5. They started at 5, and that is not a minimum. That's at 95 miles per hour. The mileage obtained at 10 miles per hour, so I go over to 10, and I go up and see what that mileage is. Let's be careful. That's not 7. These go up by 2. 6, 8, 10, 12. So that's going to be at 8. So 8, and it would be miles per gallon. That would be this scale. Now we have to be really careful. I'm going to highlight this graph because they give me x values to start. That's what the closed bracket means. And an x value to end. That's a negative 1 x value and a positive 2 x value. So it starts here at negative 1. I need to know what that value is at that endpoint. I need to know what this value is here at this minimum. And I need to know what this value is here at this maximum. So I technically have 4 critical points. I have an endpoint. I have a relative max. I have a relative min. And I have an absolute max or an endpoint. Now these two minimums I think are equal. And this is a trick question. We have to be aware of this. So I'm going to graph it. 5x cubed minus 5x squared. I'm just going to graph it in the calculator. I'm going to hit y equals. I'm going to clear it out. I'm going to type it in like it looks. 5x cubed minus 5x squared minus 5x plus 6. And let's look at their window. Their window is from, let's say, negative 6 to 6, negative 12 to 24. So I'm going to go to the window. I'm going to do negative 6 to 6, and negative 12 up until 24. I'm going to graph it. Really nice. Now, I want to find out what the value is at the endpoint, negative 1. So I'm going to hit second, calc, value, negative 1. At negative 1, the value is 1. So this coordinate here, this endpoint, is negative 1, 1. Now I want to find out what this minimum is. And it looks to be 1, 1. So let's test that. I'm going to hit second, calc, minimum. I'm going to go pass off my maximum. I'm going to enter. I'm going to go to the right of it. Enter. I'm going to enter again. And notice it is at 0.9991 or 1, 1. So this was a trick question. They both have the same minimum value of 1. They both have the same low point of 1. Now I'm going to find out what this high point is. And that's going to be located at 2. Second, calc, value, plug into 2, hit enter, and it's 16. So that endpoint is at 216. Let's read what the question asks. It says the absolute maximum. Now notice, I didn't even bother to find this spot, this relative maximum, because I knew that this spot was absolutely higher than that spot. So the absolute maximum is 16 at x equals 2. The absolute minimum value is 1. But that's located at 2 spots, negative 1 and 1. And they want you to use a comma to separate the answers. It is not a coordinate, it's 2 x values.